GJ Math. This is the exponents chapter for grade 11, but we're going to start with a recap of all the exponent laws you need to know by now. You started learning these laws at about grade 8 or 9, so let's just revise. Law 1 says, if I multiply the same base, I'm just going to add exponents. So this is going to be x to the power 2 plus 3, giving me x to the power 5. Second one, I am not going to multiply the bases, I'm only going to add the exponents. The next one, I'm not going to multiply the bases, but I am going to add the exponents. So many students make a mistake with this one, but the final answer would just be 2 to the power 6. Please just tell your teacher that you know this is 64. If the number is small enough, just type it in the calculator to leave it in a numerical value, but if it goes past the 10,000s, just leave it in exponent form. Law 2 says if I divide similar bases, I am going to subtract exponents. So this answer would just be x to the power 8 minus 2, x to the power 6. The next one, the base is 16. I take the first exponent minus the second one. I can't simplify it anymore. Law 3 is the one with the brackets. So if there's exponents inside and outside the brackets, then I multiply only the exponents. So in this case, it would be x to the power 2 times 5, leaving my answer as x to the power 10. This one, the base 3, don't change that, just leave it as a 3. And then multiply the exponent. So 2 times 3 equals 3 to the power 6, which would be 7 to 9 is my final answer. Law 4, very similar to Law 3, but now I have multiple bases on the inside. So in this case, each base gets the exponent. So the x already had a squared, but I'm just going to multiply it by 3. And then y, I don't see the exponent, so it's a 1. And then my final answer would be x to the power 6, y to the power 3. Okay, last one. I am going to multiply each base with the exponent. So 2 to the power 2 times 5 to the power 2 gives me 4 times 25. Final answer is 100. So now we're going to look at a few applications or deductions that's also sort of exponent laws, but they don't call it that. So very important. The first one, anything to the power 0 is a 1. Now, if we look at this first sum, the 37 does not have an exponent of 0, so that just stays there, but the k turns into a 1, and the final answer is just 37. The next one, the entire bracket is to the power 0, so the answer is just 1. The next one is about roots. So what it says is whatever the exponent on the inside is, that goes on top, and the roots exponent goes at the bottom. So this one would be, the standard one would just be a to the power 1 over n. So the inside goes on top, the root goes at the bottom. Let's do 2 examples. So this would be r to the power 2 over 3. The next one would be k to the power 4 over 5. Now, negative exponents. So whenever an exponent is negative, you move the base to the other side of the fraction. If it was at the top, it moves down. If it was at the bottom, it moves up. Let's apply that a few times. In this case, once again, the 37 does not have an exponent, so it stays where it is, but the k moves down. The next one, very important rule. If it is a fraction in a bracket and it has a negative exponent, you just flip the fraction. So this is going to be 3 over 5. The minus I now used to flip it, so I'm just going to put a square on the outside. The final answer is 9 over 25. Now, again, the same rule. I am just going to flip the fraction. That's my final answer. Now with this one, you need to move anything that has a negative exponent. So the 2 stays where it is. The 3 stays where it is. But the x has a negative 2, so that becomes x squared. And the y has a negative 1, so it actually moves to the top. So it's y to the power 1. And that's my final answer. You can just leave it like that. Let's look at a few sums that you got in your exams or tests. This would be a typical grade 10 final exam section. So the first one, I am going to apply law 4 to this. So I'm just going to rewrite the 8 as 2 cubed, a cubed, b 9, all to the power a third. Now, law 4 says I need to multiply every exponent on the inside with the one on the outside. So 2 to the power 3 times a third, a to the power 3 times a third, and then b to the power 9 times 1 over 3. Now it's important, all those fraction rules that you learned in primary school and that you forgot whenever you started using a calculator. So let's apply that now. Remember, if I multiply fractions, if there's a number at the top and the bottom, they can cancel out. So this one would just be the 3's cancel, and this is just 2 to the power 1. A to the power 1, b to the power 3. Final answer. The next sum, this would count a lot of marks. So I would first simplify the inside. And then only at the very end, when everything is simplified, I would multiply in the outside exponent. So I'm going to start with 2 to the power 3. Now I'm going to move the negative exponent. So there's an a to the power minus 3 at the bottom. So a6 stays where it is, but a minus 3 moves up and it becomes positive. Okay, 27 I'm going to write as 3 cubed. b1 stays where it is, but b to the power minus 2 moves down, and the exponent becomes positive. This is all still to the power minus 2 over 3. Now I can just simplify a little bit. And while I'm at it, I'm going to multiply in the outside exponent. So multiply negative 2 over 3. This would be a 9, because I'm adding exponents, times negative 2 over 3. At the bottom, just going to do the same. Times negative 2 over 3. Now I can simplify a little bit. This is going to be 2 to the power minus 2, a to the power minus. So let's do this step by step. The 3 goes in there once, the 3 goes in there 3 times. 3 times minus 2 gives me minus 6. This is 3 to the power minus 2 and b to the power minus 2. Okay, so now everything that has a negative exponent moves to the other side. So this would be 3 squared b squared over 2 squared a to the power 6. Final answer would then be 9b squared over 4a6. Now we get to a few square root sums. So in this case, you can split the square root and give each base that root. So it's very much the same as law 4. I'm now just dealing with square roots. So this would be square root of 16, square root of x 16. This we know is just 4. But with this one, remember there is an invisible 2 in front. So this is going to be x to the power 16 over 2, which just gives me 4x8 as my final answer. Let's split again and give each base its own root. So this is going to be the cube root of 27 times x8, but also in a cube root, and then times the cube root of x4. I want to rewrite this in exponent form. Luckily 27 is a cube number, so that's just going to be a 3. But now this is going to be x to the power 8 goes on top, 3 goes on the bottom, x, and then 4 goes on top, 3 goes at the bottom. Now I'm just going to add them, and that's going to be 8 over 3 plus 4 over 3 gives me 12 over 3. So the final answer is 3x to the power 4. The last two sums for this video. So now I am first going to rewrite in exponent form. Then I'm just going to apply law 1 and 2. Let's do that step by step. So x to the power 5 over 2 times x to the power 1 over 3, x to the power 5 over 6. If you have a fraction like this, where it's all just multiplied, no pluses or minuses, then you can write a big base, and I'm going to add the top exponents, so plus a third, and I'm going to minus the bottom exponents. In a future video, we'll explore that much more. But in this case, you can now just type it in your calculator, or just show your fraction rules if you still remember them. So the LCD between all of those, sorry, that must be a 6. The LCD between all of those will be a 6. And then I multiplied this first one by 3. I multiplied this one by 2, and then minus 5. So the answer then would be 15 plus 2 minus 5 gives me 12 over 6. Final answer is x squared. Let's look at the last sum. So at the top, I'm going to multiply into the bracket. At the bottom, I'm going to split and give each base a cube root. So in this case, this would be 64, but I'm going to rewrite in exponent form. So 64 is 2 to the power 6. use your shift fact button if you are unsure. Okay, I'm going to multiply that by 2 over 3. Then a to the power 6 times 2 over 3, and then b times 2 over 3. The bottom, I'm going to give each its own cube root, so that's also 2 to the power 6, but cube root times cube root of a to the power minus 9, and then cube root of b to the power 18. So now if I simplify at the top, 6 times 2/3 actually gives me, again, 12 over 3, so 2 to the power 4, a to the power 4, and then b to the power minus 2. So remember our rule, when we have exponents on the inside and the outside, the top one, or the inside one goes on the top, and the bottom is the outside exponent. So a minus 9 over 3, and then b 18 over 3. I can then simplify that as 2 to the power 4, a to the power 4, b minus 2, that's all over 2 to the power 2, a to the power minus 3, and then b to the power 6. Okay, I am going to move the negative exponents and simplify the rest. If I look at the 2's, I can say it's 2 to the power 4 minus 2. A, 4 stays where it is. A minus 3 moves up and becomes a positive exponent. B6 stays at the bottom, but b squared moves down. Then my final answer is going to be 4a7 over b8. I hope all of these rules make sense and you could remember some of them. Please go back and do individual sums in the video step by step if you are still struggling. I promise we will do extra videos on this because it is extremely important.
If this video helped you, please like and subscribe.
JJ man!